You're listening to a podcast from 702 and Cape Talk.
702 and Cape Talk.
The Naked Scientist.
24 minutes to 10 o'clock. And of course, The Naked Scientist is brought to you by The Rand Show. It's showtime. It's still on. Hey, it closes on Sunday. So you've got 2 days to get there. But sadly, you won't find The Naked Scientist because he's gone. He was here last week. How was it, Chris?
We had a blast, quite literally, Rita. It's fantastic fun. And lots of people came to see us. It was so nice to see so many people. So thank you, everyone who came and had a chat to us. And thanks also for everyone who came to see us at 702 last Thursday. That was great fun too.
Wonderful. Now, Chris, I could kick myself for not ever wondering how the moon was made. I stare at the moon, I admire it, but it never crossed my mind how the moon was made. I understand there's some new research now?
There's some more supporting evidence that tells us a bit more about where the moon came from. Doesn't say anything about whether it's made of cheese or not. We'll have to wait and see about that one. But for a long time, scientists, ever since Apollo actually, have had this idea that the moon must have formed when something pretty big, probably the size of Mars, bashed into the Earth on a glancing blow and ejected into space lots of the Earth's surface material, which then coalesced in orbit around the Earth to form our moon. And that would explain why we have such a big moon relative to the size of the Earth. Thing is, the evidence to support this theory was a bit few and far between, a bit thin on the ground. And now there's a slew of papers in the journal Nature where scientists have taken a range of different approaches to really, I suppose, bolster this theory and give it much more credibility. One of the papers looks at the prospects of finding something as large as the object that must have hit the Earth on the same sort of orbital pathway as the Earth, which is what it must have taken for the two things to meet in space, obviously. And those simulations that they've run show that, in fact, it's a lot more likely than we had first thought, maybe 20-30% likelihood. So that's certainly within the realms of possibility. Another paper looks at the isotopes of oxygen, which are different flavours of oxygen, if you like, which are present on the Earth and also on the Moon. Mm-hmm. And they're asking the question, well, for two things to meet, did they genuinely form in the same part of the solar system? Because if you've got the same chemical makeup of oxygen in one body and in another body, that suggests they did genuinely form in the same area of space. And they seem pretty comfortable on the basis of these observations that could happen. And then a third paper looks at the question of, well, what happened subsequently? Because when Apollo brought back rocks from the moon, they were analysed in the laboratory, and there were some very great similarities between what the Earth's made of and what the moon's made of. And scientists said, well, this doesn't really fit, because after the moon was made and the Earth was there was material raining in from space and covering both bodies in a veneer of material subsequently. So the chemical composition should actually differ, because the moon's much smaller than the Earth, and therefore it should be hit less often. Now they've used much more sensitive techniques and reanalysed Earth rock and moon rock, and what they find is that you can see evidence for a subtle difference in the composition between the two, which does fit with the theory. So it looks like this whole idea of a big splat from space, something comes in about 4.5 billion years ago when the Earth was first forming, hits the moon, ejects lots of the I'll try that again. Mm-hmm. Hits the Earth's surface, ejects lots of crust material into space, and this makes the moon. It now looks a lot more tangible.
But before this research, Chris, can you tell us a bit more about what was the prevailing theory about how the moon was made?
Well, no one really had any sound evidence for anything. All we knew is that we had this very big moon, and we probably have got it to thank for the fact that we're all here, because by being in orbit around the Earth, what it's done is to stabilise the Earth's obliquity. The Earth is tilted at about 23.5 degrees off of its vertical north-south axis, and it very rarely changes much from that. There's very few departures, and this keeps the climate very stable, which has, of course, helped life and complex life to evolve here. If you contrast the Earth with Mars, then Mars has at various points in its lifetime flipped itself from being up down to sort of sideways onwards. So it's like falling over sideways in terms of the way it works. And the Earth hasn't done that, and that's why Mars has had such catastrophic changes in climate. But prior to these present theories, people thought that perhaps the moon may have been formed by the Earth spinning a bit fast and spinning some stuff off into space, but that doesn't really fit either. So this really is the best theory that we've got.
Our lines are open for you, 021 446 0567 or 11 883 0702. The Naked Scientist is on the line and answering your questions. Sean, we start with you. Sean in Mondio.
Hi, Brady and Chris. Thanks.
All good,
Hello?
Sean.
Good morning, Sean.
Yes, carry on.
Okay, I just want to ask Chris. The scientists say photon hasn't got mass, but in a photoelectric experiment of Einstein, the photon knocks an electron out of a metal, and also sun attacks, according to relativity, attacks right towards it. So if something attacks something must have mass. So how come a photon hasn't got mass?
Okay.
Hi, Sean. Yes, it's a paradox, isn't it? How can light push things around? Because light can also budge things. We've just been talking about things clobbering the Earth. Well, in fact, the impactor that destroyed the dinosaurs, or probably helped to wipe them out, was almost certainly dislodged from the asteroid belt out beyond Mars, and probably this occurred because the asteroids out there were being nudged by light or photon pressure from the sun, and this dislodged an asteroid and put it onto an earthbound course. So photons, particles of light, definitely can exert a force, but they don't have any mass. And the way we reconcile this is that they do have energy, they do have momentum. They only impart that momentum when they hit something. So the light is travelling along at the speed of light. If it had mass, it couldn't do that. Therefore, it must be massless to obey the rules of physics. But when it strikes a surface, the energy from that photon impacts on that matter, and it will therefore perturb the electrons. It will impart momentum to that particular body that it's hit, and then you have something actually being affected. So that's the current thinking.
Okay, thank you very much, Sean in Mondio. And then who came in first? It was Bella in Centurion. Good morning.
Good morning. I just want to ask, has the thyroid gland on children, does it have the growth? Because I've got a grandnephew, and he's 9 years old, but he has got the stature of a 4-year-old. He's not a dwarf. He's perfect. His brain is perfect. But he is not growing. And I just wanted to know, has that got anything to do with the thyroid? Does the thyroid gland help it to grow?
All right, thanks, Bella.
The thyroid is a gland in your neck, and in healthy people, it uses iodine, and it connects it up with some other chemicals to make the hormone thyroxine, which is secreted into the bloodstream. It visits every cell in your body, gets inside those cells, and then triggers genes to be turned on in your genetic code, which are linked to metabolic rate. And people who have an underactive thyroid have a lower metabolic rate. They have poor repair and maintenance of their tissues and organs. People who have an overactive thyroid, too much thyroxine, have a high metabolic rate. They feel very hot and bothered all the time, and they may have diarrhea and tummy upset. And again, they can have symptoms of an overactive thyroid, including hair changes, skin changes, and anxiety attacks, and a fast heart rate. It's a very important hormone, and too little of it is destructive, too much of it is destructive. It doesn't normally get linked to a growth problem, though. And if someone is of small stature, they could be completely normal because there are big people and small people in the population, so there may be absolutely nothing to worry about. Children also grow at different rates to each other, and as long as they're within a range that we've defined as normal, which, of course, one has to be sensitive to race as well, because different races grow at different rates. There's a report out this week showing that the Dutch in the Netherlands are the tallest people in the world, and they have changed their ultimate heights by 20 centimetres in the last 200 years, so a very dramatic departure. Therefore, it's important to consider race, because some races do grow taller, some smaller, and therefore they're going to have different rates of acquiring those heights. And then there are other causes why small stature may occur. And if it's clear that brothers and sisters are growing at a different rate to this individual, it might be worth having them checked out, because there is a hormone called growth hormone, which is produced from your pituitary gland at the bottom of your brain. This is secreted at night, and it drives the growth and development of all of the tissues in your body. As an adult, it helps you to keep your body repaired and in good nick. As a child, it is fundamentally important for the growth of your long bones and an acquisition of your final height. And there are a small number of people in the population who can't make this or don't make this, or it doesn't work properly, and they do have under height. So that might be what's going on. But it's probably nothing to worry about, but it might be worth getting checked out. And is this person eating properly would be my number one thing, though, because to grow you need energy, and you can put 30% of the energy you burn in a day as a child just into making yourself get bigger. If you're not eating properly, you're not absorbing calories, you're not actually taking that food on board, then that is the number one reason why many, many individuals are of under average stature. So I would check that the individual eats well and absorbs their food properly as well, because that's going to be the most common reason why someone isn't growing.
Okay, good luck, Bella. I'm sure everything will be fine. Shall we go to Kagiso in Roodepoort? Hello, Kagiso.
Hello.
Hello, yes.
Hi. I want to ask about dreams. Last week, I woke up in the morning, I switched on the radio, and then I kind of fell asleep again. But then I had a dream that was about whatever the radio was playing on, and I want to ask, how does that work with the dreams? And the other question is, can you use that then to make someone dream something that you want? That you can make the dreams become whatever.
You influence someone's dream because something.
When he falls asleep.
Okay, all right, very interesting, Chris.
Hi, Gary. So when I was driving around in Joburg last week, there's a big billboard by the road, a massive headline on it, and it said, "This is not subliminal advertising." And I thought that was quite clever, actually, because it got my attention. There you go. The thing about dreams is that we don't really understand what the point of them is, but we do understand what's happening when someone's having one, because if you make measurements on a person's brain, what you can see is that when they're dreaming, the regions of the brain that do certain roles and decode things for us during the day, so the part of the brain that does hearing, the part of the brain that does seeing, they become very active with patterns of activity which reflect what you would see if that person were really experiencing those things when they're awake. Effectively, the brain is recreating or making up pictures, which, because it's exactly the same pattern of activity that would be produced if you really experience that thing during the day, you believe in your sleep that this is real. Why we do it, we don't really know, but we know it's pretty important, because if you stop a person or an animal from dreaming, then it goes mad, and in some cases will die. If animals don't get proper sleep, then they become very unwell and they die. Humans will go mad. They develop schizophrenic-like symptoms if you stop them from sleeping and dreaming properly. If you don't also dream and sleep properly, you have a higher risk of things like Alzheimer's disease. So we know it's important. In terms of actually fundamentally whether you can influence dreams, well, dreams almost always have some connection to your experiences. You don't dream things that are so wild and wacky that they're things you've never seen. So they're probably recreating or recrudescing pathways or experiences you've had before. It may be the brain's way of processing or making sense of information, or chopping out and throwing away stuff it doesn't need anymore, like this program. No, I'm just kidding. So that's why when you listen to a radio program, if your brain has been triggered into a certain pattern of activity by the program, but then you're very, very close to sleep and you drop off again, echoes of that activity that the radio program induced in your brain may then rattle around for a little while and then trigger a dream state, because you're susceptible to dreaming at that time. But in terms of whether or not this can be used to influence people's dreams and dream state, I think it's an imprecise art.
Okay. And then is it Johan in Zikufle? Good morning to you, Johan.
Good morning. Good morning, Reedy and Chris. What a privilege to be able to pose you a question, and thank you for taking my question, which is as follows. I know somebody who, about a year or two ago, suffered from a kidney disease which rendered both of his kidneys totally useless. He found that his son, or they found that his son, a man 25 or 30 years his junior, was a perfect match. And he then donated one kidney to his father, and both are now perfectly healthy with one kidney each. And my question is, when eventually the father dies, of obviously not a kidney-related disease, but eventually when he dies of old age or whatever, would the son be able to have his kidney back?
What a lovely question,
Yes.
and what a lovely outcome as well. I mean, that just goes to show how good it is, I presume, that both are in good health. I thought you were going to say, how can one survive with one kidney when normally we need two? But the fact is that you have two kidneys because then you have a reserve, what we call a renal reserve. It's a bit like having two engines on an aeroplane. You can fly an aeroplane just about with one, but two is good because that way if one goes down, you've got another one. And it means that things fly faster and more smoothly if you have two, but you can get away with one. It's the same with kidneys, that there's enough processing capacity in the kidney that unless you stress the system, you're going to be absolutely fine with one kidney. In terms of whether or not you could reacquire the organ you've donated away, then the organ that you put into somebody when you do an organ transplant, the organ is your cells. They contain your DNA. Therefore, that organ remains part of you in terms of its genetic fingerprint indefinitely. It doesn't change in any way. The only exception to that rule is that because it's plumbed into your blood supply, immune cells from the recipient's body will come into the organ, and you will find white blood cells and other bigger cells called macrophages lurking in the kidney that has been donated once it's in the new recipient. So there will be a degree of mosaicism, as we call it. There will be some cells from the recipient, but most of the cells in that organ that do the business of actually being a kidney, they remain the donors. So you could theoretically take that out and put it back into the original donor's body, and assuming there were no other nasty cells in there, because there are other risks with organ transplants because of immune suppression, assuming that wasn't an issue, you should be able to take the organ out, put it back into the donor patient, and it should then resume working normally back where it came from.
Okay, that's Johan in Zukufle. Thank you for sharing that, and thank you for calling. We like that a lot. Shall we go to Peter in Pinelands? Hi.
Hi, how are you doing?
Good, welcome.
Now, what the question I want to ask is, what determines the color of the sea? For sometimes it's green, sometimes it's blue, other times it's grey.
Short and sweet.
Hi, Peter. There's a number of aspects to this. The most important determinant of the sea's colour is what's in the water. Because water, as you know, when it comes out of the tap, is actually colourless in and of itself. If you look at a glass of water that you've poured, there is no intrinsic colour there. But if you add things to the water, you can adjust its colour. Certain salts and chemicals can adjust the colour of water, but most important are organisms. The sea is full of life, and ideally, hopefully, and there are certain species of organisms called phytoplankton. These are tiny marine microorganisms which are plant-based, and they contain photopigments, green stuff, which can capture energy from the sun and use it to turn the energy of the sunlight into chemical energy that can then keep that organism going. They're tiny marine plants. So a lot of the reason why the sea appears green is because of these tiny algae. And you can see this from space because it happens seasonally. As ocean temperatures and currents change, you can see the colour of the sea change. And scientists are actually using satellites to keep tabs on the colour of the sea now, because this can in fact be used to predict when there's going to be a cholera outbreak in certain places. Now, the other reason that you have colour of water and why it looks a lovely blue colour is partly down to the chemistry of water. When light hits water, water molecules stick together. They're very sticky. The hydrogen of the water sticks onto the oxygen of an adjacent water molecule and makes what we call a hydrogen bond. And this is why water has some of its exciting properties. But that bond also is quite good at absorbing energy at the red end of the light spectrum. When you shine white light at the water, therefore, red tends to be absorbed by the water, but the blue colours travel much further into the water. And if you're therefore looking at what colours come back out of the water at you, you're going to see not very much red because it's been absorbed, and if you take red out of the spectrum, you get a bluer colour, and that's why ice and water look more blue. But if you don't illuminate them with white light, they're not going to look blue. So water itself is colourless. That's a trick of the light that you're shining on the water.
Is it Mark in Centurion? Hi.
Yes, hi, good morning. I just want to go further on to the explanation that Chris gave regarding how the Earth's moon was formed. And there was another theory originally that it might have been acquired as a one-ring moon that Earth then came to the Earth's gravitational field, and therefore it was captured there, and it was then obviously went into orbit. Because that's because the same theory of having been formed by the mother body wouldn't really hold water then with the Galilean moons of Jupiter. I mean, the four original moons that Galileo found, because they are so totally different from each other. I mean, Jupiter's a gas giant, and Io being very very much basically with sulfuric and sulfuric volcanoes. I mean, Europa is covered in water, supposedly and ice. Callisto and Ganymede are also volcanic, but just rocks. They are totally different. I mean, they couldn't have been possibly formed by slamming to Jupiter. They must have been acquired. So how would one compare the two theories then?
Okay, your line is not so great, Mark, but I think we got the question. Chris?
It's a good point, and thank you for raising it. And the thing is that all of these things are theories because no one was here 4.57 billion years ago
Yeah.
to know. But what has been the wrinkle in the arguments is, well, if this was a wandering object, it must have come from somewhere else in the solar system to then be picked up by the Earth and captured, assuming that could happen. And indeed, that was on the table as a possibility way back when. When Apollo then brought back samples of lunar rock to the Earth and we analysed them, scientists were pretty surprised to see that the moon was made of almost the same stuff chemically as the Earth. This means that any object that was captured by the Earth must have been made or born or produced or assembled in the very same cosmic neighbourhood as the Earth. And this is really tricky to reconcile with something wandering in from outside the solar, or outside further from our own orbits in the solar system, because then it would have a different chemical makeup. And this is what scientists have been grappling with, which is why they think that an object made or born quite close to our own orbit then hits the Earth and ejects the contents, shoving it all into orbit around the Earth, and the cores of those two bodies merge to make the Earth's own core. And the reason I'm raising this point is that the moon does not have a core, or if it does, it has a very tiny one. The moon is made almost entirely of rock. Now, if it was an object coming in from outside our own orbit, one would have expected it to have differentiated and had the same sort of structure that our body does, with some kind of core and then some kind of outer crust. And the moon doesn't have that. It's made entirely of sort of crust material, which is more in keeping with something slamming into the Earth and then ejecting product of the collision out into space that then reaccretes and forms the moon in orbit around the Earth.
Thank you so much, Chris. Have a lovely weekend. We'll speak again next week.
I'll certainly try my best. Thanks, everyone. See you soon. Bye-bye.
Bye-bye. Bye-bye. And just a reminder again, it's showtime with The Rent Show. The Rent Show is back and for 2 days now. And this time with even more exhilarating, exciting shows, from stunt performances to stage performances, attractive events, fun and fiesta. Did you go, Thomas?
No, I didn't.
You didn't this time, ne?
This time around.
They didn't have lollipops and stuff, ne?
No.
Okay. There's something for the whole family. It's on until this Sunday, the 12th of April, at the Joburg Expo Centre. That's in Nasrec. Tickets are available at CompuTicket. Rent Show. It's showtime.